Hello everyone, welcome to the video. In this video, I'll be discussing on a research paper on cloud computing. We'll be looking into the introduction of the research paper, the objectives, cloud computing security challenges, homomorphic encryption, undercover sharing techniques, proposed framework, data distribution strategy, access control mechanisms, performance evaluation, results findings, practical implication, future work, and the conclusion. The research paper which I'll be discussing today in this video is the Unveiling the Protective Potential of Homomorphic Secret Sharing in Secure Cloud Computing, which was published on September 2024. Let's look into the introduction of this paper. It delivers services like servers, storage, and software over the internet, offering the business flexible, scalable access to resources without significant upfront investment. It also plays a very important role in enabling the remote work as well as collaborating with those. However, the growing reliance and the cloud services raises the concern over data security, privacy, compliance with regulations like GDPR and HIPAA as cyber attacks and data breaches increases, as the cyber attacks and the data breaches increases. This paper will be mainly focusing on enhancing the cloud security through innovative techniques like homomorphic encryption and undercover sharing, aiming to create a secure and reliable computational platform. The objective of this paper are investigate integration of homomorphic encryption and undercover sharing, enhance data security in cloud computing, develop a reliable and confidential computation platform, distribute data across multiple servers. The main things are exploring how combining homomorphic encryption and undercover sharing techniques can work together to enhance the cloud data security, assess how integrating these methods can provide stronger protection for sensitive information in the cloud environment, design a platform that ensures data privacy and security while supporting efficient computational processes, distribute data access across multiple servers. Under that, it is mainly focusing on distributing the data for multiple users, which will reduce the risk associated with a single point of failure. Cloud computing security challenges. So, we will look into the security challenges which will be faced. Cloud computing faces several security challenges, with data breaches being a major concern. So, one of the major concern is the data breaching, which is unauthorized access to sensitive information stored in the cloud can lead to data theft or loss, has seen in high-profile incidents that have highlighted vulnerabilities in cloud security. So, there are few unauthorized access which will be accessing the main information of the data. This is one of the major concern where the cloud computing security has to look into. Another critical issue is unauthorized access, often stemming for weak authentication mechanism, allowing malicious actors or insiders to misuse their privileges to exploit cloud resources. In addition, data loss remains a risk, whether due to accidental deletion, hardware failure, or malicious attacks, underscoring the need for robust backup and recovery solution. So, the major reason for this is authentication mechanism. If the authentication mechanisms are very easy, accessing of the cloud database would be easy for the unauthorized authentications. Furthermore, insecure APIs pose insufficient or significant risk as attackers can exploit vulnerabilities in application programming interfaces to gain unauthorized access and manipulate the data. These challenges highlight the importance of protecting sensitive information, such as personal and financial records. Ensuring data security in the cloud is crucial not only to comply with regulations like GDPR, but also to avoid reputational damage and financial losses for the organization. Homomorphic encryption. It is the advanced encryption technique which allows computation to be performed directly on the encrypted data without the need to decrypt it first. This innovative method enables secure data processing while keeping the original information confidential, providing a powerful solution for protecting sensitive data in the cloud environment. The significance of homomorphic encryption lies its ability to perform operations on data without exposing its potential threats, making it deal for the scenarios where the privacy is paramount. The process works by allowing the users to send encrypted data to the cloud, where computations are carried out on the encrypted information. The cloud then returns an encrypted result, which the user can decrypt into a final output, ensuring that the original data will remain secure throughout this entire process. The key benefit of this homomorphic encryption technique is the data is confidentially during process. It is so confidential that it secures the data. The main data is not at risk, which will significantly reduce the risk of breaches or unauthorized authentication while allowing the efficiency, secure computations in the cloud. Undercover sharing techniques. Undercover sharing techniques offer a robust method for protecting the sensitive information by dividing the data into multiple parts or shares or distributing them across different servers or locations. So the data will be usually divided or distributed into different servers or kept in different locations. This will ensure that no single server has complete access to full data set, greatly enhancing security and privacy. So the main reason for dividing the data into different or storing into different servers is that the whole complete data set will not be available in one particular server. So accessing a particular server will not give you the complete data set or complete information. The process begins with data segmentation, where the sensitive data is split into smaller encrypted segments. Each segment is stored separately on different servers, making it highly challenging for unauthorized users to reconstruct the original data. To further strengthen this approach, redundancy and distribution are employed, which shares are spread across geographically diverse locations. This not only reduces the risk of localized attacks but also mitigates the impact of potential hardware failures. So the initial method is segmentation, where the whole data is being segmented or distributed and stored in different servers. The apart from this, other method which has been enhanced to this is reducing the redundancy. So the common patterns in all the data will be reduced so that even though if one of the servers is being accessed, with the help of that data, the unauthorized person cannot access the whole complete data set with the other servers. By implementing these methods, organization can minimize the risk of single point of failure and increase the overall security. Even if one server is compromised, only a fragment of encrypted data is exposed, which is useless without other shares. Additionally, this technique will help in compiling with data protection regulation by ensuring sensitive information is adequately safeguarded across the distributed environment. Proposed framework. The proposed framework integrates homomorphic encryption and undercovers sharing techniques to establish a secure cloud computing environment. This framework is designed to protect the sensitive data while supporting efficient computation and strict access control. The process begins with data encryption. where homomorphic encryption is applied to secure the data before it is being processed or before it is shared in the cloud. This ensures that the data remains confidential even during the computation. Following encryption, undercover sharing techniques are employed to divide and distribute the encrypted data across multiple servers, enhancing the security by preventing any single entity from accessing the entire dataset. In addition, access control mechanisms are implemented to ensure that only authorized users can interact with the data. This layer of protection incorporates authentication as well as the authorization protocol to safeguard the sensitive information and restrict unauthorized access. A diagram can further illustrate the framework, which will be showing the encryption process, data distribution across servers, and the interaction between the users and cloud systems. Data distribution strategy. Distributing the data in multiple servers is very much important in enhancing the security and data integrity. By splitting the sensitive data and storing it into various locations, the risk of unauthorized access is significantly reduced as no single server holds a complete data set. This approach complicates potential attacks, acquiring adversaries to breach multiple servers to gain access to the full data. Furthermore, distributing the data across servers improves data integrity, as even if one server is compromised or experiences data corruption, the other servers maintain intact share of the data. Another key benefit of this strategy is mitigating single point of failure. With data spread across multiple servers, the system remains operational even if one server fails or is attacked, ensuring continuity and minimizing the disruption. So, in case even any one of the servers is being accessed by unauthorized authentication, the whole data will not be gained. Only a part of the data will be gained, and even though in chance or in other cases, if that part of the data is being corrupted, so the other parts which have been distributed to other servers will be saved and you can use that data. This built-in redundancy increases availability and ensures that the users can still access services even if the server goes down. Additionally, it provides fault tolerance, allowing the system to function correctly despite hardware failures. In the event of disaster, the distributed nature of data allows for quicker recovery and restoration of services, making it a robust approach for both the security as well as for reliability. Access control mechanism. Implementing a strong access control mechanism is very much important for protecting the sensitive data. So even now we have segmented the data stored in different servers, accessing data, providing a strong access control for the data is very much important. Restricting the access for unauthorized access is also important. Only the authorized authentication should be done so that particular authentication can be taken. By maintaining stringent access controls, organization can foster trust among users and stakeholders, reassuring them the data is secure and handled responsibly. In the proposed framework, various access control measures are employed like role-based access control RBAC, which assigns roles based on their responsibility, granting them access only to the data they need. Additionally, the multi-factor authentication adds an extra layer of security by requiring the users to provide multiple forms of verification before accessing the system. So, before accessing the account or system, you have to just go through the accessing mechanism so that to verify that it's you, so that you'll be access to that data. The framework also includes audit trials to log access attempts and data modification, ensuring that all actions are tracked for monitoring and accountability purposes. Authorization is very much important in maintaining the data privacy by offering granular control, allowing the users access only to specific data necessary for their roles. Furthermore, dynamic access management will enable real-time adjustment to the access right based on user behavior or changes in the roles, enhancing the security as well as the adaptability of the system. Let's look into the performance evaluation. To evaluate the proposed framework, performance tests were conducted with the goal of assessing its effectiveness and efficiency in securing the cloud data through the homomorphic encryption and undercover sharing techniques. The test environment involved a setup that included multiple servers and standard hardware specification along with relevant software. Several key metrics were evaluated during the test. Encryption decryption time was measured to gauge the speed of data encryption and decryption, offering the insight of efficiency of the proposed methods. Proposing overhead was another critical metric as it assessed the additional computational resources requiring by the framework, helping it understand the impact overall the system performance. When compared to the traditional encryption method, the framework's performance was benchmarked to highlight the improvements or possible drawbacks. The key finding of this performance evaluation offered insights into the system speed, resource usage, and the overall efficiency. The results, findings, and the practical implications. The performance evaluation revealed several key findings. In terms of encryption decryption efficiency, the proposed framework showed a notable improvement over traditional method, significantly reducing the time required for these operations and enhancing the user experience. Regarding the processing overhead, although there was a slight increase, it remained with acceptable limits, ensuring the system stayed responsive. This framework maintained a strong computational efficiency even under heavy workloads, demonstrating the scalability, reliability of the real-world applications. Overall, the balance between the security and computational efficiency was achieved well. The dual approach for homomorphic encryption and the data distribution proved to effectively protect the sensitive data without major compromise in the performance. While some trade-offs such as increased resource consumption were identified, the security benefits outweighed these minor drawbacks. The proposed frameworks, which was already discussed, had a broad application in the real-world scenarios, particularly in securing the data in cloud services for enabling safe data sharing among the stakeholders. It is especially beneficial in industries like finance, healthcare, government, while protecting sensitive information is crucial. The future work and the conclusion of the paper. Future research and development in cloud security could focus on scalability, reliability, enhancement to handle the larger data set and more complex operations, as well as the real-time processing techniques to maintain security while enabling the immediate data access. Potential improvements to the process methods will be including the optimization algorithm to reduce encryption or decryption time, as well as to improve the system efficiency, along with the user experience enhancement to minimize the latency during secure data access. Further exploration of additional security techniques like integrating multi-factor authentication and blockchain technology for secure data sharing and integrity verification could provide even a great protection. As cloud computing becomes essential or very important for business like for enhancing the security, and it is very critical to safeguard the important sensitive data from the evolving threats. The processed framework combining the homomorphic encryption and undercover sharing contributes an immense innovative solution which balances the security as well as the computational efficiency with practical application across industries. Researchers are also encouraged to build on these findings, while organizations should also adopt advanced security practices which will help in protecting their cloud environments and also sensitive data or the information. This was about the paper on cloud computing. Hope you all liked it. Thank you.